everyone. Let me know if you cannot hear me. I posted the tutorial worksheet on Google Drive as usual. So you can go there to download the notes to write on. We will start the tutorial today. There's not much theory that I want to go over. The first one is combination with repetition. I will not go over the theory for this because in my opinion, it's just not beneficial for you, even if I give you all the formula. So we will actually solve the problem and I will show you how this works. The next one is binomial theorem. So the only thing you need to remember is that a plus b to the power of n can be written as a summation where you have n choose k and a to the power of k, b to the power of n minus k. Your k can range from 0 up to n. If you find this formula difficult to remember, one kind of way that you can do sanity check is that working with familiar exponent such as a plus b to the power of 2 or a plus b to the power of 3 and make sure that your formula makes sense. For example, if I apply it, this one here, my n is 2, so my k will range from 0 up to 2. And I have 2 choose k, a to the power of k, and my a here, I just keep it as a like this. And then b to the power of n minus k. If I expand it out, first I have the case when k equal to 0. So 2 choose 0, a to the power of 0, b to the power of 2 minus 0, which is 2. And then I add with the case when k equal to 1, 2 choose 1, a to the power of 1, b to the power of 2 minus 1, which is 1. And this would be the last term. And if I simplify it, 2 choose 0 is just 1. A to the power of 0 is also 1. So I'm left with b squared. 2 choose 1 is 2. A to the power of 1 is a. B to the power of 1 is b. 2 choose 2 is 1. A to the power of 2, I keep it the same. And b to the power of 0 is just 1. So you see that a plus b squared can be written at this summation, and it is something that you knew previously from other math course, I suppose. Then you can verify that, okay, probably that I remember this formula correctly. I will also post a proof later for this, like combinatorial proof, in order to help you memorizing this formula. Because I feel like if you understood it, then remembering it would be easier than just purely memorize without understanding at all. If there is no question about this one, I will let you work on question 1. Again, these all the things that you need to know for binomial theorem. I don't know if you will cover the negative version in this course because I didn't see they cover it before, but maybe now Masu changed his mind. I don't know. I will have to see what he did in the lecture. But for now, this is all you need to remember for binomial theorem. I will walk you through question 1 and then I will let you do question 2 by yourself and then I will take it up because they are very similar. It just kind of build up in terms of difficulty. So here we want to find how many non-negative integer solutions are there to this equation. If you think about it, non-negative just mean greater than or equal to 0. One solution you might have in mind is that x1 equal x2 equal up to x5 and equal to 2. There is one possible solution. Or you can do x1 equal to 10 and x2 up to x5 equal to 0. This is also a possible solution. So we want to count how many such solutions are there that satisfy the equation. And I will convert this problem into the problems of you have 10 identical balls. And you want to distribute into 5 bins. Why is it related to this equation? It is because, for example, there is a solution, x1 equal x2 equal up until x5 and equal to 2. It is the same as you are putting 2 balls in each of the bin. Or if you're looking at this solution here, where x1 equal to 10, it is the same as you are putting all 10 balls into bin 1, and then bin 2 up to bin 5 are empty. Which means the problem of how many non-negative integer solutions to this equation is the exact same problem with how many ways are there you can distribute 10 identical balls into 5 bins. Is there any question at this point? I'm converting from the problem of equation into the problem of distributing balls in bin. And another representation that you can think of, instead of drawing the bin itself like this, what I can do is I can just draw the divider between each bin, right? I don't really have to draw the bin itself. I can just put the divider here and they would be equivalent representation. This one means that my bin 1 has 2 balls. This one means that my bin 2 have 2 balls. This, my bin 5 have 2 balls. If I put all 10 balls next to each other, and then all 4 vertical lines next to each other like this, what it represents is my bin 1 has 10 balls. My bin 2 have 0 balls. My bin 3, bin 4, bin 5 also have 0 balls. Is exactly this representation. And this is equal to the case when x1 equal to 10, x2 equal to x3 equal x4 equal x5 and equal to 0. So the number of ways that you can arrange this sequence is the number of non-negative integer solutions to this equation. Because each arrangement, each distinct arrangement of this sequence of objects will give you distinct non-negative integer solution to this equation. So they are equivalent problem. And if we think about how many ways are there, I can arrange this sequence. This is a sequence of 10 balls and 4 divider. So you can use permutation with multiset. In total, you have 14 objects and 10 objects of the same type, 4 objects of another type. And this would be the same as 14 choose 10 or 14 choose 4. If you read in your textbook, there is combination with repetition, then you will use n equal to 5 and k equal to 10. But I don't recommend memorize the formula because you can just mess it up. Sometimes students are mess up what is n, what is k, and then they calculate the wrong value, which gives you incorrect final answer. So I don't recommend that. I recommend you to convert into a problem like this, where you know exactly what is the balls and what is the bin, and then what are you trying to permutate here. Any question about this one?
Yeah. Sorry, why is it 14 and not why would n be 14 here, or at least not n? Just where does the 14 come from? Sorry.
This one
Yeah,
is
yeah.
because you're trying to arrange this sequence, right? And in this sequence is the same as this sequence, like where you have 10 balls. So you have 10 objects come from the ball, and then you have 4 divider to distinguish.
Oh, okay,
Yeah.
okay, yeah, I get it. But then wouldn't there be a 5 included somewhere because there's like 5 bins or whatever?
You have 5 min, but it means that you have 4 divider, right?
Oh, okay, okay, I get it. Thank you.
Yeah. If there's no other question, I will let you work on question 2. Is very similar, just a little bit more difficult, not too much. I will give you 5 minutes to think about this. Here you have new restriction. You will have to think about how am I guaranteed to satisfy those restrictions. If you have any question, feel free to put it in the chat for me. Okay, so for this one, we have restriction for the lower bound. Imagine you are having 3 bean. And you are having 50 balls, identical balls to distribute into those bins. And you want to make sure that I will have at least 0 balls in bin 1. So I don't have to do anything, right? For sure, bin 1 will always have at least 0 ball because the number of balls cannot be negative. I want to make sure that I have at least 5 balls in bin 2. In order to fulfill that, I can just put 5 balls into bin 2 before doing anything else, so that, okay, for sure, in bin 2, there will always be at least 5. And for bin 3, I will put 10 in them to make sure that bin 3 always have at least 10. And after that, I can distribute the ball however I want, because now I already satisfy the 3 conditions. I only need to distribute the remaining balls however I want. Then after you distribute 5 balls into bin 2 and 10 balls into bin 3, then the remaining balls that you have left is 50 minus 5 minus 10, right? Because originally you have 50 balls, but you already have to put 5 in here and 10 in here. So now you are left with 35 balls. So the number of ways that you can distribute the balls into those bins such that these conditions are satisfied is the same as how many ways are there. You can distribute 35 balls into 3 bins without any condition. Because now, even though you don't impose any restriction, then these 3 are already met because you already pre-distribute the balls into them. Then the number of ways that you can distribute 35 balls into 3 bins is the same as the number of ways you can arrange this sequence where you have 35 balls and then you have 2 divider to represent 2 bins, 2 vertical lines. The number of ways you can arrange this is 35 plus 2, choose 2. Or you can say 35 plus 2, choose 35. Or 35 plus 2 factorial to get the total number of objects that you have and divided by 35 factorial because you have 35 balls. They are identical. And then 2 factorial because the 2 vertical lines are identical. Any question about this problem? I really want to make sure that you understood everything, because later we will have a bit more challenging problem that is in similar style. So you need to make sure that you understood what's going on here. If there is no question, I will move on to question 3. I will give you time to think about it. Just one thing is the third one, you don't need to use binomial theorem. When I combine the question, I made a mistake. This is not a question about using binomial theorem. But the first 2, yes, you have to use binomial theorem, then it will give you very easy way to answer. I will take this up at 3:36. Okay, let's look at this one together. For the first one, first I will remind you of the binomial theorem. I will just write here again for convenience. For the first one, I'm looking at summation from k equal to 0 up to n choose k, and 3 to the power of n minus k. I see that it kind of matched the format of my right-hand side, right? However, it's not quite there yet because, okay, I have the term n choose k, that's good. I have the term something to the power of n minus k, that's also good. But I didn't have the term a to the power of k. Why is that? Why is one term missing here? How can I rewrite it so that that term appears? You multiply this with something, and that something act as a to the power of k. But when you multiply this with the question mark, it has to be equal to the expression itself. So the only possible option is that multiplying with 1, right? Because if you multiply with any other number, it will give you different expression. I hope that you see why these two expressions are equal, because 1 to the power of k is 1 for every k. And then the whole thing multiply with 1 is just equal to the expression itself. So now I have n is equal to n, a is equal to 1, b is equal to 3. So I can write this one as a plus b to the power of n, which is 1 plus 3 to the power of n, which is 4 to the power of n. Okay. So we have this expression is equal to 4 to the power of n. And I leave it as exercise for you to prove it combinatorically. Show that these two expressions are equal to each other without manipulating it algebraically. You can see here is n choose k times n choose k. We actually did this question on Monday. I don't know if you remember, but we know that n choose k is also equal to n choose n minus k. And then this is the same process as, let's say, I have n black cat, and then I choose k. I choose k cat from n black cats. And then I have another n orange cats. And I want to choose n minus k cat from the orange one. Then it is the same process as out of 2n cats, I chose n cats in general. Because I have n black cat and n orange cat. If I chose k cat from here and n minus k cat from here, then in total, I chose k plus n minus k, which is n cats out of total is 2n cats that I got. So you will have 3 is equal to 2n choose n. And that is what we did on Monday as well. we were showing that with like the lattice path where you're just going to the right or going up. Any question about this one? If there is no question, I will let you work on question 4. You will see that it is something built up from question 2, but it will be more difficult because now you have the upper bound as well, not just lower bound. You might want to use formula for cardinality of union of 3 set. I will take this up at 353. Let me know if you have any question. You might find that using complements will be easier. Okay, let's look at this together. So if we think about it, we want to find the number of solutions that satisfy both lower bound and upper bound. So I will denote the one that we want to find is satisfying lower bound and satisfying upper bound, like this. And what is it equal to? We see that if there is only lower bound, like, and my pen is kind of not working anymore. If I only have the restriction in the lower bound, give me a minute. Okay. If I only have restriction in the lower bound, then it will be easy, right? Because it's basically just question 2. I can calculate it very easy. So we want to relate the number of solutions that satisfy both lower bound and upper bound to the number of solutions that satisfy lower bound only. Then we can say that is equal to number of solutions that satisfy lower bound, subtract number of solutions that satisfy lower bound and not satisfied upper bound, right? Because if you think about it, if there is a set of all solutions that satisfied lower bound, then in that you will see some satisfy upper bound as well. Now see here. And then the rest will not satisfy upper bound. So there are only 2 possibilities when you satisfy lower bound. Either you satisfy the upper bound or you don't satisfy the upper bound. And now our upper bound is x less than or equal to 15 and x less than or equal to 20 and x3 less than or equal to 25. If we want to find the complement, we have to negate what we want. So the complement, first we negate this part. X1 is not smaller than or equal to 15, means that X1 is greater than 15, right? But then we want integer, so we can say that it is greater than or equal to 16, and will become or. X2 is at least 21, X3 will be at least 26, like this. So now we can say the event A is the event when X1 is at least 16. B is when X2 is at least 21. C is when X3 is at least 26. Then we have the cardinality of those that satisfy lower bound and not satisfied upper bound will be cardinality of A union B union C. Because if it satisfies A or B or C, and then we have to make sure that it also satisfies the lower bound. And here you can use the formula given. This part here, I will not go over every single term, but I will go over, let's say 3 terms, and then you can imitate what I did to produce the same result. For example, if I want to calculate cardinality of A, how many non-negative integer solutions are there such that it satisfies the lower bound and also satisfied A, which means I want X1 plus X2 plus X3 is equal to 50, but then X1 is at least 16, X2 is at least 5, and x3 is at least 10. And you will see that these become the distributing balls into bins problem that we did for question 2. We first give bin 1 16 ball, give bin 2 5 ball, give bin 3 10 ball. Then the remaining ball that we have left, I believe is 35 minus 16, which is 19. So we have to distribute those 19 balls into 3 bins, which give us 19 plus 2, choose 2. And you will get the same number for cardinality of B and cardinality of C. And you can use the same logic to find cardinality of A intersect with B. So now I want x1 plus x2 plus x3 also equal to 15. And I want it to satisfy A, which means x1 is at least 16. And then x2 is at least 21. And x3 has to satisfy the lower bound, which is 10. So I can distribute 16 into bin 1, 21 into bin 2, and 10 into bin 3. Then the remaining number of balls I have left is 5, I think so, or 3. I think it's 3, yeah. So now you have to distribute 3 identical balls into 3 bins. And they just 3 plus 2, choose 2. And if you do the same for B intersect C and A intersect C, you will get the same number. So we cover the first 3 terms, all the intersection, now only the last term. We have to think about how many solutions are there such that x1 is at least 16, x2 is at least 21, and x3 is at least 26. You will realize that there are no such solution exists, because if they satisfy all these minimum number, then their summation will exceed 50. It will be larger than 50. Therefore, no such solution exists. And then you just add everything and subtract everything together, you will get this quantity. And then after that, you will take the number of integer solutions that satisfy the lower bound, subtract this one, and you'll get the final answer for this question. I will upload the formal solution since the student from previous tutorial also asked for that. And if you still have any question, you can come to office hour or post on PSL. If there is no question, I will stop the tutorial today and I will see you on Monday.